See Lindelof videos. Dr. Deb endorsed. Inverse trigonometric functions. Just want to start off by this thing. These are equivalents, and you're going to see these written lots of different ways. A textbook or a professor may describe this as the inverse of cosine x. The professor may write inverse cosine x. This is not a negative, this is not an exponential value. This is symbolic, and it's read the inverse of cosine x. Another way that you'll see this often is you'll see it written as arc cosine x. They are exactly equivalents, so something to know so when you see them. So here's some really important stuff. Here's some really important stuff about this. Start off this way. I'm going to start off this way by saying some stuff that we know. So say, well, cosine of pi force is equal to, go to my unit circle, or not. Go to my unit circle, I go to pi force, find the cosine value right there, right? Go back to it, was equal to square root 2 over 2. So think about this for a second. So the way we write it now is this. We say, if we're going to graph cosine, we say, what's the angular value, don't we? And then we write down what's the cosine of that same angular value. So specific to this case, we'd say our angular value, our x value is pi force. Its trigonometric ratio has a value of square root 2 over 2. All good? And we're cool with that. But what happens is, if we take the inverse of something, to take the inverse of something means that you switch its domain and range. That is to say, you take its y values become its x values, and its x value becomes its y values. So with that in mind, I can do the same thing. I can say, well, therefore, what is the inverse of cosine of square root 2 over 2? That asks the question, if the ratio is square root 2 over 2, what angular value is that attached to? And what's the answer? Has to be, right? One is asking the question xy, the other one is asking the question yx. Pi force. Pi force. There are some really important things that you have to know about that. And that one thing, Brendan, is that when we look for our answer, it must be on this interval here. We will only look on this interval right here, where the theta value, the angular value, is greater than or equal to 0, but less than or equal to pi. We will not look down here. And the reason for that is because all cosine values are accounted for here. If I go, let's say, to here, Brendan, I've repeated it. This cosine, because this cosine value is already accounted for here, isn't it? And if I go to this cosine, if I go to the cosine of this angular value, well, that's already accounted for right here, isn't it? So we only need this piece right here. It is very, very important that you know that. It is very, very, very important that you know that. And that the range values must be between -1, I'm sorry, the domain values must be between -1 and 1. So let's try a couple. Somebody tell me why I'm lost. So let's try. Arc cosine of square root 2 over 2. What is arc cosine of square root 2 over 2? How would you find that? This is not the angular value, right? The question is, what angle has this cosine value, right? So we know where to look, if I can get there, which I can't, Brendan, because as we all know, I'm dumb. Square root 2 over 2. So I'm going to start up here on the unit circle. I'm going to stay inside this purple band right here. And here it is right here, isn't it? This is the cosine value, isn't it? So if the cosine value is square root 2 over 2, then the angular value must be pi force. Must be pi inverse. What if I did this, though? What if I said, what is arc cosine of, what is arc cosine of 4/3? Why do we know this? How do I know this is undefined? Tell me something about the number 4/3. Because remember, and this number here has got to be greater than or equal to -1, but less than or equal to what? To 1. Is it? So this is undefined. All right. I hope this was helpful. If you have any questions or comments, please let me know. If you haven't already subscribed, Kylie wants you to subscribe as soon as possible.